Welcome to Amar Rashid online math class. Today we start calculus. That is differentiation. Basically, calculus is divided into two cases. We have differentiation, we have integration. All right. This is the first video, of course, we can see. Problem 1. We want to differentiate all these ones with respect to x. So when you see WRT, it represents with respect to x. All right. To start with, let us indicate solution here. So the first one says y is equal to x to the power of n. All right, we can see there are two variables here. We have the y, we have the x. So other than x and y, the rest are constants. All right, so this n here is a constant, it's not a variable. So it represents what? The power of n. So y equal to x to the power of n. We want to differentiate this, but there are two quantities here that can keep changing. We call them the variables. We say the y variable, we have what? The x variable. But x is changing with respect to y. Likewise, y is changing with respect to x. So therefore, we want to differentiate y with respect to x. Alright, so whenever we want to differentiate a function where the variable is raised to a power and there is a coefficient in front of that variable, what do? We multiply the power by the coefficient. Of course, according to our eyes, we cannot see anything here. But mathematically, there is a 1 here. So this, what we have in front of x, that serves as the coefficient, multiplies the power here. So n multiplies 1, we have n. So we write our variable again. The variable is the base. So what do next? We subtract 1 from the power. So when we subtract 1 from n, we have n minus 1. So therefore, to differentiate a function like this, we simply multiply the power by the coefficients. So what next? We say the power minus 1. So this is what we have. So the second one here says y equal to ax to the power of n. So the only difference between the previous and the current one is the coefficient. Here the coefficient is 1, here the coefficient is a. So we want to differentiate y. We differentiate y with respect to x. So what we have here, x, is the variable of differentiation. For a and n, they are constants. So to differentiate this function, the power multiplies the coefficient. N multiplied by a, we have an. We must write what? The variable, the base, the variable x. So what next do? We subtract 1 from the power. So we say n minus 1. So the derivative of ax to the power of n is an x to the power of n minus 1. The result we get after differentiation is what we call the differential coefficient. It's also called the derivative. Alright, so the C part of problem 1 says y is equal to 4x to the power of 2. Y is equal to 4x squared. So we want to differentiate y with respect to x. What do? We say dy dx. Dy dx. So we are differentiating y with respect to x. So what do? The power is 2, the coefficient is 4. So when the power multiplies the coefficient, we have 8. So we must write the variable again. So what next we do is by subtracting 1 from the power. So when the power loses 1, there will remain 1. So remember, 2 minus 1 is 1. So the result is 8x. With a power of 1, we don't need to write anything again. So this is the differential coefficient. This is the derivative, and it is with respect to x. So D part of the question says y is equal to 2px to the power of 3, 2px cubed. We want to differentiate y with respect to x. Remember, the only variables we have are y and x. How about 2p and 3? They are constant values. They are not changing at all. Even if y is changing with respect to x, x is changing with respect to y, 2p, 3, they are not changing. So what do? The power is 3 and the coefficient this time around is 2p. So what do? The power multiplies the coefficient. 3 times 2p. 3 times 2p is 6p. But we must write the variable. So what happens to the power? The power loses 1. So 3 minus 1 is 2. So we have 2 here. So the result we get after the derivative, after differentiation, is the differential coefficient, is the derivative. This is what? The first derivative. Because sometimes we can differentiate further to get the second derivative. We can further differentiate to get what? The third derivative. But the first differentiation is the first derivative. Now, the next one is E. It says y is equal to 1 minus t x squared. Y is equal to 1 minus t x squared. Don't forget that we want to find dy dx. How do we know that we want to find dy dx? We are asked to differentiate with respect to x, and this function is represented by y. So we are differentiating y with respect to x. So even if you see 1, you see t, all of those ones are constant as far as this function is concerned. So what do we need to identify here is the power, which is 2, the coefficient, that is what? 1 minus t. So to differentiate y with respect to x, the power of this x multiplies the coefficient of this x. What is the power of this x? The power of this x in the function is 2. What is the coefficient of this x? The coefficient of this x in this function is 1 minus t. So the power multiplies the coefficient. When it happens, what do we get? 2 times 1 minus t is 2 multiplied by 1 minus t. So we must write the variable. The final thing we do is to say the power minus 1. So 2 minus 1 is 1. So therefore, this is 2 multiplied by 1 minus tx. Remember, a variable with a power of 1 is just the value itself. So this is what we get. So we go to F. Y is equal to 4. Y is equal to 4. We want to differentiate 4 with respect to x. Alright, but it seems difficult. It seems impossible because we cannot, our physical eyes cannot see x. But the only thing is that mathematically there is x. So we say this can be written as y is equal to 4x to the power of 0. You and I can testify that a value, a variable, a numerical value that is raised to a power of 0 is 1. So if we have 4 alone, but we want to force x to present, we say 4x to the power of 0. So now we've not differentiated. Now that we want to differentiate, so we say dy dx. So the power of x is 0, the coefficient of x is 4. So 0 multiplied by 4 is 0. So we must write what? The variable. So what happens to the power? We say minus 1. 0 minus 1 is minus 1. But remember, this 0 is multiplying what we have after 0. So right from the beginning of our school, we learned that 0 multiplying any value is 0. So therefore, this gives 0. So we can deduce that whenever you are differentiating a constant value, the result is 0. Alright, so we come to G part of the question. Y is equal to 4Q. Alright, Y is equal to 4Q. Q is a letter of the 26 alphabet we have. But as far as this function is concerned, Q is a constant. 4 is a constant because we want to differentiate with respect to x. The fact that this function is independent of x. What does that mean? The fact that this function does not contain x, we can say this one is a constant function because it does not contain any x. And we are dealing with a function with respect to x. So this one can be written as 4q x to the power of 0. If you say x to the power of 0, what do we get? We get 1. And that one multiplying 4q, we have 4q. So 4q can also be expressed as 4q x to the power of 0. Alright, so now we want to differentiate y with respect to x. Alright, so what do we do? Search for this x. This is the x. What is the power of x? Is 0. What is the coefficient of x? Is 4q. So to differentiate, the power multiplies the coefficient. 0 times 4q is 0. Remember, 0 multiplying any value is 0. So what about 0 multiplying 4q? Is 0. We have the variable. So what next we do? The power subtracting 1. So we get minus 1. 0 multiplied by 1. 0 minus 1 is minus 1. But 0 is multiplying x to the minus 1. So basically, 0 multiplying any value, we have 0. So this is still emphasizing that whenever you differentiate a constant function, the result is 0. You differentiate a constant function, the result is 0. Being a constant function doesn't mean that it must stand without a letter. Q is a letter, but this is a function of x. How do we know? We are differentiating with respect to x. So 4q is a function of x, only that the x is there with a power of 0. Okay, so we go to H part of the question. Y is equal to 0. So having understood that we want to differentiate y with respect to x. Having understood that differentiating a constant is 0. Differentiating a constant is 0. So likewise, when we want to differentiate 0, the result is also 0. So thank you for watching. Don't forget to like and share the video. Bye bye.